Hi everyone, welcome back. In this video, we will see various kind of algorithms to allocate processes to the freeholds, guys. I mean, when you are going to have the main memory, this main memory contains the operating system and it is going to be partitioned either fixed partition or it might be a kind of variable partition, right? In general, we are going to discuss with respect to the variable partitioning. However, these algorithms can be able to work for fixed partitioning also, right? So if you look into variable partitioning, the complexity is going to be more when you want to maintain what are the freeholds and what are the memory spaces which are full. For that reason, to maintain the freeholds and to maintain the full spaces, we come across with two solutions. One will be a bitmap, another one will be a kind of linked list, right? So among those, the best one is linked list. So while explaining these algorithms, I am preferably going with the data structures called a linked list. So in linked list, the advantage is I can able to split the node wherever is required, and I can able to combine if they are in the contiguous manner, right? So this is what we mentioned in the earlier video, so that it can reduce or it can improve the performance, right? Increasing order of the starting addresses so that merging will be very easy, right? So what are various kind of algorithms are there means, first one will be the first fit. Guys, first fit is a kind of algorithm which is used for to allocate the process, right? How it is going to allocate the process? It can work on the principle of first free is big enough, which means that it is going to start scanning the, for example, let me take a simple example, you will get a clear idea. If I say there will be a kind of memory which contains 200 KB is one partition, 400 KB is one partition, 600 KB is one partition, 500 KB is another partition, 300 KB is another partition, and 250 KB is another kind of partition. Okay, now we got the request in such a way that the requested processes are like 357 KB, 210 KB, 468 KB and 491 KB, right? So you have to satisfy this requested process by using the algorithm called first fit, right? So this algorithm is saying that first free is big enough, which means that whenever you encounter a process like 357 KB, you have to start searching from the starting, right? So is 357 KB process will fit in the 200 KB? No. Then I will move for the further. If I go with further, is 357 KB is fit here? Yes, it will be fitted. So the remaining will be, right guys, why I have taken this one? It is because of I am trying to take the variable partitioning, right? Variable partitioning, right? The leftover will be 33, am I right? 43 KB is free, right? Next 210 KB is process required. So is 210 is supposed to fit here? No. And is 210 is supposed to fit here? No. Can it fit here? Yes. 210 is supposed to fit here. Then what will the memory space is enough here? That will be almost 390. Am I right? Yes. Next I got the request for 468. right? Is the first one is satisfied? No. Is the 43 space satisfied? Is 390 not satisfied? Then I will go with the 468. If I go with 468, you are going to have 32 kb is free. Now I will try to come up with 491. Is 491 satisfied with 200 kb? No. 43 no. 391 no. 32 no. 491 in 300 no. 250 no. Which means that 491 process is not at all satisfied with respect to this first fit algorithm, right? So guys, which means that once you got a request, you will try to start searching from the first and go for placing at the location wherever it is fit, first fit. That is the principle of first fit. So the advantage of this algorithm is it is the faster one and the best one among all the algorithms. Hope I will explain why it is the best one by comparing with all other algorithms, right? Fine. Next one will be next fit. Guys, in next fit, the principle what it is going to follow is last allocation free, which means that it is going to work like as first fit, but it will start scanning from where you left earlier. This is what we call it as next fit, right? So I can say that if I say this is 200, this will be 400, 600, 500, 300 and 250. I will get the process first 357, which is fit here, good, and the leftover will be here 43. Next 210. 210 will start searching from which location? From here itself. 210, then leftover will be 390. Then 468 will satisfied here. The leftover will be 32. Hope you understood. From I am not going back again. 491, is it satisfied anywhere? No. Then it will come back. It is not satisfied. So in next fit also 491 is not satisfied. In best fit also, in first fit also 491 is not satisfied. Right? This is the algorithm how it will work, which means that from which location where you left, from that location onwards it is going to start its execution again. Right? According to the simulation, the next fit is not better than the first fit, guys. Right? Fine. Next one will be the best fit. Best fit. So best fit means it will follow the principle called smallest free is big enough, which means that generally if you are going to have the main memory like this 200, 400, 600, 500 and 300 and 250, if I got the request like this, like 357, 210, 468 and 491, once if I got the first request 357, it is going to scan the entire list first and it will try to check with the process which is wasting less amount of wastage. I mean, does 357 is fit in 200? No. Is it fit in the 400? Yes. Is it fit in the 600? Yes. Is it fit in the 500? Yes. Is it fit in the 300? No. Is it fit in the 250? No. Then what might be the possibilities of placing for 357? One will be 400, one will be 600, one will be the 500. If I am going to place in 400, how much amount of memory is going to be wasted? 43. If I am going to place in the 600, how much amount is going to be wasted? Which will be almost 243. Is it right? Yes. I think it is true. If I place in 500 memory location, it will be around 143, right? Which is less than 100. So what is the best one here? What is the smallest free big enough here? 357 is enough. So if I place here, 43 amount of memory is going to be wasted. Fine. Next, if I get a chance to execute 210. 210 will be the best fit at which location? 210 will fit at cannot possible at 200. Try to observe. For this I will do. 200 is not possible, but 600, 500, 300, 250 is possible. Out of these 4, which one will waste the less amount of memory wastage? 250. So here it is going to get 210, so that 40 MB is going to be wasted. Now 468 is best placed at here, so you will waste at 32 MB. And then 491. If I am going to place the 491, which is enough for us to place here, which means that 190 is the MB wasted, right? Is all the process requests is satisfied? Yes. In best fit, these requests are satisfied, right? So that is the way you can able to execute the best fit algorithm, right? But the thing is, guys, the best fit algorithm is slower compared to first fit. Why it will be slower? Because for each and every process request, I have to start scanning from left to right. Complete free holes it has to identify, and it has to identify the efficient one. So best fit is not best as compared to the first fit, guys, right? In general, I can say this best fit can be defined in 2 ways, guys. Once again, one will be in terms of best available fit, another one will be in terms of best fit only. Okay, so if I say here best available fit means the example what we have explained so far. What I explained so far will becomes under best available fit. If you go with best fit only, which means that I will give with an example. Again, same example: 200, 400, 600, 500, 300, and 250. If I got the chance 357, obviously the best fit for 357 will be 400 only. For 210, the best fit will be 210 only. For 468, the best fit will be 500. Good, because it is going to waste less amount of memory space. What about the 491? 491, in the best available fit, it will be allocated to what? 600. But in the best fit only, 491 will be waited for to free the 500, because it is checking for best fit only. Means if I place 491 in the 500, I can able to wasting only 9 KB of memory. But if I place in the 600, I am wasting 119 KB of memory. That is the difference between best fit only and the best fit available. Hope you understood, guys. Okay, fine. So this way this algorithm is going to work. And the another kind of algorithm will be worst fit. Guys, in the worst fit, so what it will do now? It is going to select largest size among all free holes. That algorithm we call it as worst fit. I can say it as largest free partition is going to select, right? So again, worst fit is not the best compared to which one? Again, first fit. What is the reason? In the worst fit also, for each and every iteration, I have to scan, right? So for example, again I am trying to take the same example: 200, 400, 600, 500, 300, and 250. The requests are in the order 357, 210, 468, and the 491, right? Now what will happen if I try to take the 357 first request? That will be allocated at the worst location, right? The largest free space. Among all the things, first I am going to scan the entire thing. What is the largest free space? Definitely at here. If I go with 357, what will be left over? That will be 3, 4, 243. Next I will get 210. What is the largest space? Obviously 500. Here it will be done. What is the amount of memory space is going to be wasted? 0, and it will be 9, and it will be 2. Next I am going to get 468. Now can I able to place the 468? No, it couldn't possible. This is the way your algorithm is going to work. If the 468 is going to be placed, I will go with the next one. Right? So this is the way the worst fit algorithm is going to work. Right? Again saying worst fit is not the best compared to the first fit. Okay. There will be one more kind of algorithm is there. We can call it as quick fit. Right? So it will take very less time compared to all the things, but the thing here is how it will work. It is going to maintain list of various kind of most frequently sized processes, most frequently used sizes it is going to maintain, and it will execute accordingly, right? But in the real time it will be the difficult one, because we don't know exactly how your required request will get into the functionality, right? That's the reason quick fit is not the best one. But if you are able to find, or if you are able to identify, if you are able to guess what are the various kind of most frequently used sizes, then definitely the quick fit is the best one. But prediction is not the correct one always, right? So these are the 5 types of algorithms that we are using to allocate a processes to the free goals. Okay. So out of all these things, which one is the better one? Obviously, first fit algorithm is the best one out of all the 5 process allocation algorithms. Right? Hope you understood this particular video clearly.